This is the first lecture on signals and systems, and this will give you an introduction to signals. And what we do is we start by defining the term first. So we try to answer the question, what is a signal? Now a simple definition goes something like this. Any physical quantity that is a function of time is a signal. Now let me repeat that. Any physical quantity that is a function of time we call as the signal. Now symbolically we represent it as xt. Now we could have used some other symbol, but we are going to use xt. Also note that this is a rather simple definition of the signal. In general, a signal could be a function of more than one variable, but for the time being, we are going to restrict to this simple definition. Now we'll make the idea of signals clearer by taking a few examples. First, consider the water level in a tank. We are all aware of the use of overhead tank that we use in our homes, and typically we fill it up with water in the morning. So as we fill it up, the water level goes up. So this is our water level. And as we use it during the day, the water level falls. Therefore, water level is a quantity which changes from time to time and therefore can be considered as an example of a signal. So initially, when we fill the tank, the water level rises rather rapidly and thereafter it falls slowly. That is one example of a signal. Let's now take another example. Consider room temperature. We all know that early in the morning, room temperature is rather low. So if we plot now, let's say T versus XT, where XT represents the room temperature. So early in the morning, it will be low, maybe 10 degrees, 12 degrees, whatever. And as the sun rises, the temperature will increase. And as the sun sets towards the evening, the temperature will decrease. Therefore, this is one more example of a signal which is changing with respect to time. Let's take another example. But before that, let me clear the slate here. And the second example, the third example rather, that we consider is the sound signal. See, whenever a person speaks, so let's draw a person here. Okay, so there is someone here, and when he or she speaks, a pressure wave is set up in the air. And if you look at the pressure at any point in the air, that is a function of time. So now if you plot t versus xt, it will again be a random function of time, but this time the signal varies more rapidly. Let's take one final example, that of traffic lights. We are all aware of the use of traffic lights, and we know that from time to time they change their color. For example, at one time the color could be green, then it may change to amber, finally it can become red. So the question now is, which is the physical quantity that is changing with respect to time? Well, let me select the pen again. So if we now plot the time versus the wavelength, then when it is green, it remains constant at some value. Let's show it by the green color. When it becomes amber, it jumps to a new value. Let's say this one. And when it becomes red, it again jumps to a third value. So therefore, in this case, you will find that it is the wavelength that is a function of time and therefore represents a signal. So we have seen, we have studied the definition of the signal, and we have also seen some examples. Next thing we do is we study the classification of signals. Now signals can be classified in many ways, but one way in which they can be classified is non-electrical signals, which we have studied so far, and the other category is electrical. Now in most of the practical systems, you will find that the non-electrical signals are converted into electric signals. As soon as we say this, two questions arise. One is, why do we do it? And second is, how do we do it? So let us answer the first question first. Why do we do it? Now, one reason is, there are two reasons as to why do we do it. One is that transmission is easy. Transmission is easy. As an example, suppose we have someone here who is delivering a public address. Okay. And there is an audience which is sitting at some distance, and there are many here representing the audience, and the distance is considerable, so that if no equipment is used, the signal cannot travel really very far. At this point, the signal is going to be quite weak. On the other hand, if you use, let's say, a microphone followed by an amplifier and then use a pair of wires, and at the other end you put a speaker. So now the signal in the electrical form is conducted to a considerable distance quite easily by a pair of wires. So you can see that transmission of electrical signals is quite easy compared to the transmission in the mechanical form. There is another well-known example. Suppose you have a radio transmitter. It handles electric signals which are connected to antenna, which sets up an electromagnetic wave, and at a considerable distance away, this will be picked by the receiving antenna. So transmission is very easily done over a large distances. So that is the first reason as to why do we convert the non-electrical signals into electrical form. Second reason is processing is easy. Processing is easy. Let me show you some examples, but again, let me clear the slate first. The first example we have already seen, that of amplification. The output from the mic is quite low and it needs to be amplified. And these days electronic amplifiers are available which easily raise the level of the signal. Now if you consider a digital computer which handles electric signals, digital computer which handles electric signals is capable of doing all kinds of processing. If you want to add two signals, it can be done. If you want to multiply two signals, it can be done. If you want to integrate a signal, it can be done. If you want to differentiate a signal, it can be done. And try to imagine a non-electrical system where all these processing has to be done. You will find it very difficult to do so indeed. So in this session, what we have done is we have defined what a signal is. We have seen number of examples of signals. We have seen one classification of signal in which the signals are converted from signals are classified into non-electrical and electrical types. And we have also said that in most of the systems, the non-electrical signals are converted into electric signals, and the reason being that transmission is easy and processing is easy. Now the other question, that is how it is to be done, will be answered in the next session.